Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss isothermal stretching and adiabatic stretching of surface films. Let's begin. We know what is surface film and how surface tension affected by the temperature. But here we discuss how the stretching of surface films under isothermal and adiabatic conditions. Let we consider a surface film and that surface film just like the film of soap water and bubble, that is film of soap water and bubble. It has two surfaces. And let the surface tension be sigma. Let the surface tension of that film sigma, and the work done on the film let dW, the small work done on that of film. The area, increasing its area, let dA. Therefore, from this data the work done dW, therefore the work done dW is equal to minus 2 sigma dA. Why the negative sign? The negative sign as work has done on the system, and 2 because the film has two surfaces, two surfaces. dW is equal to minus 2 sigma dA. We relate that equation, relate it to dW is equal to P dV, that is the mechanical work. dW is equal to P dV. So, P stands for sigma, dV stands for dA. Thus, we say P corresponds to minus 2 sigma and dV corresponds to dA, means V corresponds to A or dV corresponds to A. Here I write V corresponds to A, volume corresponds to that of area. Now, applying Maxwell's second thermodynamic relation. Maxwell's second thermodynamic relation, that is del S by del V at constant temperature is equal to del P by del T at constant volume. Here P stands for minus 2 sigma and V corresponds to A. Just write it. So del S by del A, del S, V to A, V instead of V we write A, that is del A at constant temperature is equal to minus 2 del sigma by del T at constant A. In place of ds we substitute, we know from second law of thermodynamics dq is equal to 2 T del S or del S is equal to del Q by T. Substitute here, that is del Q divided by T del A at constant temperature is equal to minus 2 del sigma by del T at constant A, or 1 by T to that of outside del Q by del A at constant temperature is equal to minus 2 del sigma by del T at constant area. As T is constant for an isothermal process, the expansion for small change in the quantity of heat dq. Here as T is constant for isothermal process, dq is equal to, here we write dq is equal to minus 2T del sigma by del T, del sigma by del T, A as constant, dA. Look at that equation. What exactly that equation told? That equation for what condition? As T is constant, as T is constant for an isothermal process, for an isothermal process, the expression for small change in heat, the expression for small change in heat, that is dq is equal to that much. Look at that of equation. Since the factor del sigma by del T is negative, means the surface tension, that is the sigma, decreases with increase in temperature. On the stretching of a film, dq has to be positive, or the work done to be done, that is dq is positive if the temperature is to be kept constant while stretching the film. Means in case of isothermal process, the heat change will be minus 2T del sigma by del T into dA. That factor negative. On stretching a film, dq has to be positive, or we can say the work done to be done if the temperature is to be kept constant while stretching a film. Means how exactly we get here? On stretching a film, dq has to be positive, or work has to be done. Positive in the sense work has to be done, from isothermal expansion, isothermal stretching of film. On stretching of film in isothermally, This is the isothermal stretching of that surface film. What happened? Work has to be done. Next, adiabatic stretching of the film. How we conclude? For adiabatic stretching, consider a surface film. Again, consider a surface film. Here, consider a surface film. Again, that is just like soap solution. Soap solution, just like soap solution that formed within a frame. That formed within a wire frame. We take a wire frame. Let the wire be AB. Here, let the wire be AB. Side over that of frame, as shown in the ABCD. ABCD. This is the side over the frame ABCD. Suppose that no heat is either allowed or to enter or leave to that of system, means we take adiabatic stretching, means heat is constant here. Thus, the stretching of the film takes place under the adiabatic conditions. Here the stretching that change to the position as A dash, here B dash. This is the force F, the stretched force be the tau, the tension force due to that of stretching. So, during adiabatic case, what happened? For adiabatic process, the quantity of heat, the quantity of a heat, that is del Q, is expressed as m Cp del T, where Cp is the specific heat at constant pressure. Here we take del T is equal to del Q divided by m Cp is equal to, now substituting the value of del Q, here dq value is substituted here. We have minus 2t del sigma by del T at constant A dA divided by m Cp, that is for del T. Now, when the area is greater than 0, the film is stretched adiabatically. When the area, small area, is greater than 0, means that is the film is stretched adiabatically. That indicates the film is stretched adiabatically. Adiabatically in the sense heat will be constant here, and the temperature, then the temperature falls, that is del T, change in temperature less than 0. Here the temperature falls means the change in temperature less than 0, which means the rate of change of surface tension, the rate of change of surface tension with temperature with temperature T will be negative, Thus we can say, surface tension of the film decreases with temperature. Surface tension of the film decreases with temperature, or temperature decreases, surface tension of the film also decreases. So, with the help of this video lecture, we understand how stretching takes place in isothermal and adiabatic process of a surface film. This is the isothermal stretching of surface film. We take the surface film as an example of film of soap water and bubble. It has two surfaces. So, the surface tension, work done, then we compare it to that of work done and applying Maxwell's thermodynamic relation, and finally get how the temperature change in heat is produced. So, we observe that on stretching film dq is positive, that means work has to be done here. In case of adiabatic case, adiabatic stretching of surface tension, what happened? We get how temperature is related to that of surface tension, and finally we observe the surface tension of that of film decreases with that of temperature from that of adiabatic stretching of surface film. So, with this useful and informative notes, let me wind up this session. Thank you.